Alright, so today we're going to talk about rhombus and squares. It says rhombi because that is plural of the word rhombuses. You guys remember in elementary school doing rhombus? With the slanted square basically. Looks like parallelogram, looks like a slanted rectangle. Alright, so rhombi have the same properties of parallelograms. So we did all these properties with parallelograms. They apply for rhombi as well, for rhombus as well. And you have three additional properties. Your first property is that you have four congruent angles. Joseph, move your desk so where you can see. Your diagonals are perpendicular. And the last one is that diagonals bisect opposite angles. Alright, because there's so many properties, this is why I told you guys make sure you're doing your homework so you can use your packets on your test. Because there's so many properties, makes your life so much easier if all you have to do is read the directions, figure out what shape we have, and then look at the properties. Alright, let's look at number 1. It says, each quadrilateral below is a rhombus, so find the missing measures. They told us that JK was 12, write that in, and JN was 7. Okay, because our diagonals are going to bisect each other, and the diagonals are perpendicular, let's draw in a right triangle there. That is super important.
We draw those
If you want to, yeah. But right now, we're just going to kind of split this rhombus up into a triangle. Alright, so if I'm looking at this rhombus as a piece of it, which would be the triangle, they told me what one side of the triangle was. I know what the outside is, so 7 and 12. What can I do to figure out what this piece right here is? Not 180. Those are angles. Pythagorean theorem. If I have two sides, I can always figure out the third side. So we are going to have 7 squared plus x squared is equal to 12 squared. You can type that right into Desmos. And what do you get for x? If you want to solve it by hand, you can do that too, but it's kind of pointless. Not pointless, but we can practice using Desmos.
9.7.
9.7. We're going to round to the nearest 10. So that means this little piece here is 9.7. Okay, we use Pythagorean theorem to figure that out. Let's take out your headphones, AirPods, all that. You can't learn this just by writing what I'm writing.
How did you get that?
I did Pythagorean theorem. So if you worked it out by hand, you would get 49 plus x squared equals 144. Subtract the 49. Take the square root. Get 9.7. All right, JM is going to equal what? In a rhombus, all my sides are congruent. So all my outside sides are congruent. So JM is 12. What about JL? How do you get 14?
I added 7.
Good, because your diagonals bisect each other, so each piece there is going to be 7. All right, MN is going to equal what? 9.7. It's just as if we did Pythagorean theorem twice on the other side. This is 9.7. And so what do you get for MK? This whole entire diagonal.
9.4.
All right, so to find MK, you're going to do 9.7 times 2, and what do you get?
19.4.
19.4. Any questions there? All right, let's look at number 2. Number 2 says that EF is 23, and then that DF is 40. If DF is 40, that means this whole entire side is 40. But I need each individual piece. What's half of 40? That's 20, and that's 20. Because I know it's a rhombus, I also know that this is a right angle. So I can break this rhombus up into a triangle, so I can solve the other part of the diagonal. I have 2 sides, I need the third side. What do? Pythagorean theorem, since we're solving for that guy there. So if I want to set up Pythagorean theorem, I have x squared plus 20 squared is equal to 23 squared. The side across from your right angle is always your seat, that's your hypotenuse. So what do you get for x? Type this into Desmos. X squared plus 20 squared equals 23 squared. Round to the nearest 10.
Is it x squared plus 24 23?
Equals 23 squared, yep. No one has an answer?
11.
You should get 11.4. Do you guys know how to type this into Desmos, or do you want to see how to do it? All right. So that means that I'm going to write 11.4 here. All right. So what is GF? Nope. GF right here. The outside.
GF is
23. What about HF? 20. What about GH? It's one side of the diagonal. 11.4. And then what about GE? The whole entire diagonal. Huh? 11.4 plus 11.4? 22.8. All right, the sides are typically pretty easy. Yes? All right, I want you guys to do number 3 on your own, but I will get you started. On number 3, they told you what the diagonals are, so how can you fill out that diagram? For number 3, they gave us that RT was 22, so that means I'm going to make this 11 and that 11, because 22 divided by 2, I know I need each diagonal, or each part of my diagonal to be 11. So if US is 18, the whole diagonal is 18, each piece is going to be what? 9. All right, just like we've been doing, I want you to focus on the fact that Let's just take one part of the rhombus. Right angle there in the middle. What can we do to figure out what RS is? I just set this one up. What'd you do? So you did 9 squared plus 11 squared equals what? X squared. So did you get 202 is equal to x squared? 9 squared plus 11 squared? You take the square root, what does x equal? What'd you get? 14.2. Okay. So that means that this outside piece is 14.2. And theoretically, the entire outside is 14.2. Alright, so BT, see what BT is, that's 11. UV is 9. RS is 14.2. And ST is 14.2. All right, let's look at number 4. On number 4, let me zoom in actually. All right, on number 4, we have angles. I don't have sides. What you need to know about a rhombus is that your angles in each corner are congruent. So if this angle down here is 38, that's what they gave us. Angle 3 is also going to be 38 degrees. And because opposite angles are congruent, what's 4 and 5 going to be? They're each going to be 38 degrees. Okay, so we at least already have 3 angles. Angle 3 is 38 degrees. Angle 4 is 38 degrees. And angle 5 is 38 degrees. Based on what I know, this angle and this angle have to equal 180. Well, I already know that these angles together equal. What's 38 plus 38? Okay, so this angle down here is 76 degrees, which means that these two angles combined is also 76 degrees. Is this making sense so far? Okay. So, same side angles have to equal 180. How can I figure out what these two top angles are going to be together? Mm-hmm. 180 minus what? Minus 76. Type that in. What do you get? Okay, so this top angle, these two together have to equal 104. Okay, so because my diagonals are bisecting each other and they're perpendicular, I'm going to split that 104 into half. What's 104 divided by 2? So that means that angle 1 is 52 degrees and angle 2 is 52 degrees. How can we figure out what angle 7 and 6 will be? Okay, so they're going to be what? Yeah, they're each going to be 52 degrees. So 7 and 6 are both 52 degrees. What is the measure of angle 8? This measure here in the middle. How'd you get 90?
Because they
Right, because my diagonals are perpendicular, so that means that angle 8 is 90. You could also do it the long way and do 180 minus 52 minus 32. You would have what angle 8 would equal. So when it comes to rhombi, what you're looking for with your angles are that opposite angles are congruent. Because they're bisect, they're going to be basically split in half. All right, let's turn the page to properties of squares. Number 5. All right, as far as you know, a square is a parallelogram, a rectangle, and a rhombus. All of the properties that we've done apply to being a square. So number 6, it says if ABCD is a square and AB equals 11, find each missing side. Well, if it's a square, all my sides are going to be congruent, right? So all of my sides are going to be 11. We learned that in elementary school. What kind of angle do I have at each corner for a square? A right angle. In order to fill out my diagonals, let's make it into a triangle. And we can still do Pythagorean theorem. So my equation for Pythagorean theorem here is going to be 11 squared plus 11 squared is equal to what?
2.
Well, at this point, it's going to be my diagonal, right? Let's just call it x. Because I don't know what that is. So 242 equal to x squared. So what do you get for x? We take the square root. Round to the nearest 10. So your x is 15.6. So that means that entire diagonal is 15.6. Now, because I know that my diagonals are all going to be congruent, let's divide 15.6 divided by 2. So we can figure out what each piece is. 7.8. So we have 7.8 right there and 7.8 right there. Each diagonal is 15.6, so each part of it is 7.8. All right, now let's fill in what we know. What's BC? 11. What about AC? 15.6. What about BD? Yeah, because your diagonals are congruent. 15.6. And then what about EC? Good. 7.8. All right, so we already said that we know that each corner of a square is a right angle. So that means it's equal to 90 degrees, right? Let's fill in each measurement. What is the measurement of DAB? So DAB, what does that corner measure? Huh? 90. That should be 90 degrees. Good. All right, what about AEB? So AEB, what'd you get?
Because it's like diagonal.
Mm-hmm. Yeah, that's right. Diagonals are perpendicular, so it is going to be 90 degrees. All right, the measure of CBD. So CB and down to D. That's just one part of the corner. So what's half of 90? 45. So that part of the angle is 45 degrees. And last, BAC. So from B over to A down to C. 45 degrees. So when they square, It's either 90 or 45 degrees, that's all we can have. And a rhombus, and then we would give you the different measures. All right, let's skip to number 8. I don't want to run out of time. In number 8, it says, if MNOP is a rhombus, then find NP. All right, it's a rhombus. So what's special about these sides? They're equal to each other. So I'm going to have 9x minus 77 is equal to 3x plus 7. That's what I see all the time, is that you guys see sides and you start saying it's equal to 180. You cannot have a side equal to an angle measure. Remember, 180 is always our angle measure. So what do we get for x? 14. You put this into Desmos, you get x equals 14. Did they ask us for x? No, they asked us for this side, MP. But I know that all the sides are the same, so I'm just going to plug in my x to one of the sides. Plug it into this one. So 3 times x plus 7 is equal to what? We should get 49. So that means that MP is also 49. If you want to plug it into this top side, you can do that. It will still be 49. And I'm going to go a little fast here because we need to at least write this stuff down. If CDEF is a rhombus, find the measure of FED. We're just going to find x. Okay, we're not doing all that. I know that both of these angles, if it's a rhombus, will be the same exact thing. Right? If the top part is 20, the bottom part is equal to 20 degrees. So, make them equal to each other. Is that what you're going to say, Joseph? All right, make these equal to each other. Let's just solve for x. We're not going any further. You should get x equals 7. It's a rhombus. We know that our corner angle, or all of our angles in each corner, are going to be equal to each other. And we know that because it's one of our properties. I don't expect you to memorize them. What I do expect you to go back and look at the properties of each figure. All right, number 10. If STUV is a square, with SU being 2x plus 13, and WU being 8x minus 41, what would you do here? Make them equal to each other, because diagonals are equal. All right, and last one. If FGHI is a square, solve for x. This is a good one. I know that in each corner it is a right angle because it is a square. So they're just pointing to this one part. What would that equal? No. The whole thing is 90. What's just one piece of it? If we cut it in half, 45. So I'll have 7x plus 3 is equal to 45. Type in what you would get for x. Seven x plus 3 is equal to 45 degrees.
6.
X is 6. Does this make sense what we did for squares? Okay, so your homework. Your homework is homework 4, rhombi and squares, and you were doing numbers 1, 2, 4, and all of the back. So make sure you write that down at the top of your homework. 1, 2, and 4, and all of the back. Are there any questions? Oh, that was my copy. All right, if you missed any lessons, make sure you get caught up because now we're done with the parallelograms and we are going, well, for most of them, we're going to trapezoids next. So make sure you're all caught up. Yes, I will.